Good afternoon, everyone. In today's class, I would like to discuss regarding the working and functionalities of these hydraulic and pneumatic type of actuators. As in the last class, we have been discussed regarding the robot actuators introduction and different modes of actuators that are existing in the robot for different functionalities. In the today's class, we would like to discuss furtherly the four modes of operational processes existing for the work done by the actuators. Normally, you are having four different types of actuators or modes of actuation workings. First one is the mechanical mode of working. Second one is the hydraulic mode of working. Third one is the pneumatic mode of working. And fourth one is electrical mode of working. Other name of this electrical is the solenoid type of working. Basically, mechanical in the sense the external effects will be utilized, nothing but external force or pressures that are utilized manually for commencement of the work or movements by the actuators. In the case of this hydraulics, the pressurized fluids of certain viscosity will be utilized for imparting the force and pressures for the actuating of links and joints, either in the rotatory type of movement or revolutory kind of movements or else the prismatic kind of movements. In the case of pneumatics also, it plays a major role as the pressurized air or certain gases which are suitable for its operations. Hence, this pneumatics plays a major role. The electrical in the sense, the support of electricity will be utilized and the hydraulic linkage or pneumatic linkage will be utilized for the actuators working. Nothing but a combination of both this electrical and hydraulics or electrical and pneumatics. So that we can say that electrohydraulics or electro-pneumatics, as that electrohydraulics and electro-pneumatics plays a major role for the execution of the actuators working. Usually, in the case of hydraulics, today's session will be detailedly looking of overall this hydraulics and pneumatics. A basic difference the difference between this hydraulics and pneumatics and what parameters these are arranging and how what range of efficiency will be achieving in the case of this both hydraulics and pneumatics will be charting a detailed synonyms in the today's session. And the hydraulics with respect to the circuit diagram and functionality levels will be seeing in the today's class, and if possible the time permits, and we will be proceeding with respect to the pneumatics concepts also. Coming to this hydraulics and pneumatics strategy. Hydraulics, generally liquids are incompressible, as if the phases has been changed, then only we'll be having a detailed analysis of the volumetric variations. The medium, nothing but whether the object converting its medium from liquid to the gaseous or else from the liquid to the solid the volume will be getting varied for that particular material. In the case of this hydraulics, nominally we will be utilizing the fluids which are incompressible, but limits only to impart the pressure by utilizing the motors which are being operated electrically or else mechanically by the engine capability. In the case of the pneumatics, we'll be utilizing the compressor for sucking the air which is available abundantly in the environmental sector and utilize the compression range, nothing but imparting of the pressure to the air and utilizing the pressurized air for the commencement of work. In the case of this pneumatics, not only the air, any of the gas mediums which are sustainable to the pressure conditions and the temperature variations because of the impartation of these pressures have to be capable for ranging or awaiting, need to be accessible for the commencement of the work driving in pneumatics range for the actuators. Nominally, the pressures such as 550 to 690 kilopascals of pressure will be ranging according to the variational levels of actuation occurs in the case of experimental basis. That too in the case of this pneumatics systems. In the range of this hydraulic systems, high pressures can be imparted and utilized for the work agitations. Nothing but 6.9 to 34.5 megapascals of pressure can be imparted in the hydraulics, and hence due to the basic capability of pressure range, we can clearly differentiate the working nature of the actuators. Hence, the heaviest lifting conditions are getting progressed in the case of this hydraulics way of operations, utilized particularly in the actuators. And even for smooth kind of operations, perfect velocity ratio operations, conversion of the entire the power which has been generated and even for transmission of this power with varying in its directional ratio is also possible to a maximum efficiency range within the allowable limitations of the errors are possible in the case of this only hydraulic systems. Hence, moving on in depth to the hydraulic way of actuation systems. The actuator where an hydraulic energy is used to impart the motion for actions that are to be created within the different links and joints is called an hydraulic actuator. Utilization of the fluids, the best Hint for the hydraulic space is oils, pneumatics, air. As given this basic phenomenon in your mind. Basically, the actuation or movements, or as we have been discussed in the previous sessions, that the kinematics of linkages or inverse kinematics of these linkages or the homogeneous transformations based on the coordinate values are being done with respect to the pressurized liquid, as that the fluids for transmitting, utilizing these fluids and imparting the pressure. So pressure in the sense automatically the velocity will be getting increased. So if the range has been restricted, automatically this fluids will get a greater energy for its driving sector with a little incrementing of its temperature also, because the molecular collision leads to an increasing in the temperature, as that it leads to the chemical affinity levels, chemical variations. And automatically, when the pressure has been increased or imparted over the liquids, transfers the energy from an generating source to an energy that will be utilizing at a particular range or particular position in order to commence the work in a practical agitations. So practical agitations in the sense as per the requirement. Coming to the simple example of this hydraulic system. As we know the Pascal's law, a basic rule for utilizing this hydraulic power. See here in the diagram, we are having an oil tank which is filled up with respect to an fluid up to a similar range of levels. Hence, the volume of the right side of the beaker or space occupied by the fluid within the beaker is more than in the left side of the beaker. So, hence we can say in our language that's diameter, volume in the sense. Let us consider this as cylindrical object. The diameter here is very much less when compared to the diameter of this particular right side of the glass tube, which is interconnected with respect to the passage of the fluid from one range to the another range. Hence, upon inserting the pressure from the less range of less dimension range, it creates the pressure and imparts the pressure within the liquids and get the excitation towards the movement and extends the motion of this fluid towards the upward direction. And when it has been connected to the cylinder and piston arrangement, for example, this is the cylinder and this is the piston, and this is the piston which will be having maintained with respect to an metal plate which holds, which helps to hold a maximum weight of objects in order to lift towards the upward direction. So the impartation of the pressure will leads to lift the particular weights. For example, this is the car which will be utilized for arranging the cleaning purpose. Upon increasing the pressure or imparting the pressure, automatically like certain levels of increasing will lift the objects towards the upward direction. Nominally, according to our Pascal's law, the pressure that has been exerted on a fluid that is distributed equally throughout the fluid, as that the pressure will be going at this particular range that will be imparting throughout the fluid, and the work will be getting commenced in the by the overall fluid that is being lifting the weights at that particular happening. So here the actuator, in the sense the movement that is being taking place by the impartation of the pressure within the oil fans, nothing but sliding actions of the piston. See here, as the pressure has been applied in the left side direction, which is having the less dimensional range, will increase the lift in range of the heavy weights. This is a simple example you are in the Pascal's law, utilizing this Pascal's law. Coming to the hydraulics, components. Components plays a major important role here for commencing of typical tasks in order to convert this pressure to the fluid power to the particular actions. Hydraulic pump unit. So hydraulic pump unit, normally it's an actual hydraulic system that converts the mechanical power to the fluid power, particularly fluid power in the sense increasing the velocity within the molecules of the fluid for commencing the weightlifting activity. Hence, control valves plays a major important role, as we know that DCV is directional control valves. As these are utilized for the flow of this pressurized liquid from the source position to the required column entry positions, nothing but required route direction for discharging the pressurized fluid created by the pump, that too in a controlled way, and even giving the direction, nothing but the path of movement of this fluid for right commencement of the work. So how many control valves that we are having? Here we are having different types of control valves for directing the fluid and arranging the fluid with respect to variation in its ranges. First one, the pressure control valves. These are used to increase the pressure levels or decrease the pressure levels, which will change the flow velocity of the liquids. Coming to the flow control valves, it's used to control the liquid flow rate, nothing but incrementing at the discharge condition and decrementing at the discharge condition. Here the flow control valves in the sense that leads to highest discharge and less discharge. In such a way, the time consumption for filling the particular volumetric of the beam will be getting varied with respect to this flow control valves. Third one is the direction control valves. It specifies the particular way of movements for reaching from the source place to the end place. So it will be varying with respect to particular altitudes, changing in its directions towards the right side, left side, etc. for reaching the fluid from the source place to the destination place, or from the originated place to the destination place. The third point is the hydraulic motor or cylinders. It's the prime mover. Normally, we will be saying this motor is the prime mover for imparting the pressure, as that utilized for the liquid discharge and direct by these motors with respect to the control valves. Nothing but from the reaching, starting from the source position to the reaching position, there is the destination position in a safest conditions. Nominally, these motors are used wherever the rotatory motion for within the cylinders are used to convert these actions from rotatory to the linear mode of actions. See here, the hydraulic systems, these are the best examples. As we've been discussed, generally, the conditional strategy, that impartation of the pressure from the left edge of the pump, the plunger, implementing a small force over this edge leads to this the directional control valves, specifies the movement of the fluid to move in such a directions, hydraulic coil, and towards the motor, which will give a variation of big engines for lifting the vehicles in the certain altitudes up to the desired levels. Up to the desired levels. Coming to the hydraulic systems, normally these are used to control and transmit the power. As we say, that is the fluid power. And specifically, a prime mover will be utilizing for creating the pressure within the fluids and directing these flows and need to happen within the particular range. As we'll be seeing in the elevators also, and the trucks and tractors, that the motors will be getting confided here with respect to the oil tanks, and upon hydro or pneumato-hydraulic circuits will be framed up here. The outward existing cylindrical pressurized air or emulsive gases that will be entering into the pneumato side, and hence the pressure will be getting increased than the existing limitations in the case of this hydro strategy. And hence this fluid will get the pressure, so segmental pressure, in order to increase, or that causes the motion of extending the piston from the cylinder, and so that the heaviest lifting conditions will be getting possible. Unloading of the material from the truck will be getting happen, and later on, after disconnecting from the control level or control valve, automatically based on the retraction movement or fluid flow from the rest directions, has this pneumato-hydraulic sector, and pneumatic will be releasing towards the outlet to the normal atmospheric range of conditions that levels the hydraulic to a nominal range. This the part plays a major role in the case of this heavy weight lifting conditions. So directional control valves plays a major important role here for allowing the fluid or pressurized fluid for the processing of the weight liftings to a certain elevation levels. See here, simple circuit diagram, but here the directional control valve is not at all clarity. And the previous class we have been seeing the different directional control valves. There's a 2x2 valves, 2x3 valves, 4x4 control valves, 4x2 way of control valves, like that. Preferably, we'll be utilizing 4x3 way control valves. So 4 ports and 3 positions will be existing, and one middle one will be the null position, and left one will be the forward stroke conditions, and the right side position will be the return conditions. So hence 3 positions. So see here, first position, middle one, there is an off condition here clearly specifies. There will not be any connections to it. And second one, it is forward positions. So this, the second position will be achieving towards the forward position. So forward position in the sense, this is the lifting conditions of the load will be getting happened. And the written conditions simultaneously, third one, then the fluid will be direction change will be getting occurred, and the fluid will be retracting back to the original positions back again. And how the activity will be getting considered or taking place will be having a detailed discussion. This is the oil reservoir, or normally we'll be saying this oil tank, will be having a similar connectivity for entering the fluid by filtering the oil. Because why the filtering is necessary? See, in the return stroke, the fluid is also returning back to the oil tank again, draining oil to the oil tank again. Nothing but the similar fluid will be entering into the channels. And in the forward stroke, the similar fluid will be getting retracted back from this PCB to back to the oil tank back again. So at these conditions, it is entering into the different objects or different components in the assembly unit of this entire hydraulic system. Basically, we'll be utilizing different kinds of materials for its assembly. Hence, if there is any ferrous content of objects, normally will be occurring the rusting conditions. The smallest particles will be entering into the hydraulic levels, and that structs the motor for imparting the or exercisation of the pressure increment or decrement. Nominally, most probably will be utilizing the incrementing strategy. If the unwanted particles has been entered into the motor level, and in order to impart the incremental of the pressure, that will be getting disturbed for its commencement of activity. Hence, this filtering process is much more necessary while entering to the motor for regulating the fluid in order to increase the pressure for the action process to be happened. See here, the motor will suck the fluids by filtering and increases the pressure, will be entering into the second position. So nothing but, or the third position, whatsoever it may be, as per the direction control valve, and enters into the direction control valve, the fluid will be entering here and load deceleration will be getting considered. Nothing but the piston will be moving from the top dead center to the bottom dead center. So nominally already entered fluid will be drained back to the oil reservoir. So that is the return stroke considerations will be taking place when this third position came into the existence. See here, third position for the return stroke is clear cutly initiating here. If the second position has been came into the existence, then the fluid will be entering similarly like this, and here the position will be in a cross linkage. So entering fluid will be coming to this direction, and leaving fluid will be coming to this direction to this hose pipes. Hence, the fluid will be entering from the cross terminal, and this fluid will be entering in the opposite direction to the arrow mark, which is specified in the diagram. And extension of the stroke, nothing but lifting of the load from the bottom dead center to the top dead center will be getting considered. And for this opposite direction, already internal fluid will be coming in the backward direction. And from this to here, the cross connection will be getting considered here. And the fluid again drained back to the hydraulic tank or oil tank. So only change is being occurring, and rest of the part, this before entering this fluid to the this direction control valve, will be calling this as an input system, and after leaving from the DCV, nothing but directional control valve, TCV is a common nomenclature or shortcut name. And after leaving the fluid from the DCV, this is called the output of the system. Generally, hydraulic system. So input system is before the directional control valve, and output system is after the directional control valve. Hence, the operational process will be getting considered of its both the extension movement by lifting the, in order to lift the weight from the bottom dead center to the top dead center, the piston needs to make a movement. So for this condition, the second link or second position need to be come into the existence. That is what forward stroke. Hence, the fluid will be crossly enters into this direction and lifting of the load will be getting considered. And simultaneously, for return stroke to be commenced, this third position need to be highlighted. So third position in the sense actually which we are showing in the diagram, it will be getting taken place. Retracting conditions, moment of the piston will be taken from the top dead center to the bottom dead center and the oil will be returning back to the oil tank. This is the system operation and this is the layout of the hydraulic system, what we have been learned till now. See, what are the basic functionalities that we'll be considering in the case of this hydraulic components? Nominally, hydraulic actuator means it's a device, practical device that is used to convert the fluid power to mechanical power for the commencement of required tasks in the industrial sector. And as per the requirement of the work, we'll be utilizing the connectivities in order to happen in multi degrees of freedom. So multi degrees of freedoms in the sense as per the linear movements towards the positive x or negative x movements, towards the positive y or negative y movements, towards the positive z or negative z of movements. Secondly, orientational process, nothing but rotation of the links with respect to a particular inclinations. So inclinations in the sense rotating of this joint or links at a constant point to a particular theta inclinations. So rotatory joint will be getting considered. And revolutionary concepts. So happening of the same axis of orientations to be processed. So that is the rotary motions or revolutionary. So the revolutionary motions that will be considered. As similarly we have been seen in the forward kinematics and reverse inverse kinematics mechanism. Coming to the hydraulic pump, it's used for impartation of the force to the fluid from the reservoir. So impartation or getting the force applied on the fluid for moving from the oil reservoir to the circuit range, and that circuit should be energized in the case of utilizing the power which has been generated by its fluid, should convert the entire fluid pressure by entering into the circuit which has been framed up with the different connectivities, and mechanical energy conversion of this overall mechanical energy into the hydraulic energy. So entire this actions should be deflected in the case of the actions that are being done by this hydraulic power. So, and whatsoever the ways are possible, or agitations are possible, nominally those walls are being utilized for controlling the direction of the fluids in order to get the necessary operational process. Nothing but the direction, variance of its pressure increase from 1 megapascal to 2 megapascal in such a way, and flow rate in terms of its velocity with the help of the connectivities commenced in the case of this circuit. Nominally, the driving aspect or driving range, that the external power supply that is required for the motor indeed to function or impart the heaviest pressures. And the fluid which will be lifted from the oil tank, nothing but oil reservoir, always it need to be done in connectivity with respect to the motor for driving the fluid from the reservoir to the system for commencement of the entire this energy for the actuation basis with for the impartation of this hydraulic power. And the device which is called a hose pipes or piping system, nothing but hose pipes was the terminology will be utilizing generally in the mechanical language, used to convert or carry this hydraulic fluids from one place to the required place as per the connections given. So as you've been already discussed, the purpose of the fluids in order to eliminate the unwanted particles from entering to the motor and to the system level that leads to damage the overall components and its actions. And even for different walls and internal agitation movements and the sliding actions or the prismatic conditions of the actuators also will be getting damaged if the unwanted particles has been entered into the systemic range. Pressure regulator is a typical component used to increase the pressure and up to a required range or required level that is being utilized for its movement or for the actions to be commenced by the motor or imparted pressure. In this way, the entire actuational strategy will be getting considered. Coming to the applications of this hydraulic actuators, these are utilized in the case of this hydraulic jack, application of this hydraulic brakes in the different kinds of automobile systems, hydraulic ram processing systems used as sensors for giving different kinds of feedbacks to the system and its working assessments, used in the closed loop velocity control system for safety monitoring of the pressures and velocity aspects, and most probably it's being utilized in highly precise positioning for the heavy loads. Coming to the advantages point of these hydraulic actuators, these are economic, is one of the limitation we can say, and moderate in the case of some application point of view. But these are very much reliable, which supports for lifting the heaviest load conditions. The maximum range of pressures can be imparted only in the case of this hydraulic sectors. And the basic advantage is for different components is that fluid is itself acts as some self lubricant for each and every component. As the fluid flows through all the materials, it acts as a lubrication for the different components. But the limitations here are a low working speed that maintains only the slow actions commencement, and the entire this hydraulic groups makes them noisy in the case of these operations. And if at all at the connectivities, is there any deflections that are being occurred? Hence, the oil leakages will be getting taken place here. Coming to the pneumatics process, as we already utilized that, discussed that pressurized air is used in the place of these fluids, and DCVs are common, directional control valves are common, and getting the prescribed conditions on entire actuation systems to be progressed, as it will be very much safe because low pressure range only will be maintained, capable of withstanding with the human beings, and within the less economical ratio, this entire operations can be progressed. Quick actions will be getting taken place, as this the outlet or disposer will be released directly towards the atmosphere, and a return line and not necessary as with respect to the hydraulics, because again the system need to be operated for retracting to the safest position or retract position in the case of this hydraulic source. But whereas in the pneumatic source, directly releasing itself it is enough, and additional commencement of motoring sector is not at all necessary in the case of this pneumatic system. As we've been specified this, air will be getting filtered, and the FRL unit will be utilized here, filtration regulator and monitoring unit. As this the compressor, which the motor will be getting signified on, and air treatment will be taking place, and it reserves upon increasing the pressure by taking the air from the atmospheric zone, and reserves within pressurized conditions that will be getting supplied to the directional control valve for the necessary operations. So for forward stroke in the sense from P to B, it will be commenced, and lifting of the actuators or lifting of the loads or moving of this piston from the bottom dead center to the top dead center will be taking place. And hence this A will be connected to the R and releases to the exhaust. For retraction stroke to be commenced, this P is directly connected to the A, and retractant stroke from the top dead center to the bottom dead center will be getting considered, and the air already entered into the cylinder will be leading with respect to B to R connectivity and releases to the atmospheric back again. This is the signalations that will be getting considered. The directional control will play a major important role for the traveling of this pressurized air. And normally in whatsoever it may be the stroke, it is considered in the extracting stroke or in the contracting stroke. In the return stroke, automatically the entered fluid will be getting returned towards the segmental range. At the return conditions, if nominally the position has been highlighted, automatically the return stroke will be getting commenced, because the pressurized air always will be tends to escape from the internal volume or constructed volume, because almost the atmospheric pressure was very much less, and it will be eco friendly, always released towards the normal atmospheric zone. As the components such as compressor will be utilized for increasing the pressure from 500 kilopascals to 1 megapascal and even more, and air treatment, the inlet air is compressed, excess the moisture and heat is removed from the air with an heat treatment unit. A reservoir, nothing but as the hydraulic in the case of hydraulic oil tank, it is an oil reservoir and storing the entire fluids in it. Simultaneously, this reservoir stores the pressurized air in a sequential manner. Control valves and the actuator, this guides the movement of the pressurized air for the commencement of the activities. Always coming to the uh, positives and negatives of this pneumatic actuators. It's economical in range construction at an initial strategy, and it's reliable and high operational speeds are occurring. Nothing but random movements will be getting taken place, operating only at a constant force, but not an incremental decremental strategy. So straightaway quick actions will be getting taken place in the case of this pneumatic range. Finally, it resistant to the overloads. Coming to the limitations, no speed control will be existing, only the random actions will be getting taken place. Poor position speed and noisy operations. So sounds will be getting generated. So this comparisons between these two hydraulics and pneumatics will be discussing in the next class. Thank you.